It is first grade math time! If I sound excited, that's because I am, and so is this dog. You see, you have found the ultimate first grade math video. We're going to learn about so many incredible things. I would tell you everything we're learning, but that would take a bit of time, longer than this beaver's been scratching itself. And honestly, I just want to jump right in. So welcome to the adventure. The first thing we're looking at is addition. Now, we're going to review what you learned last year just to make sure we're all on the same page. And then we're going straight to double-digit addition. Wow. Just look at this plus sign. It looks so happy. I love the gloves, the shoes. It's a fancy plus sign. It definitely looks like it's ready for addition. Addition is awesome because we can see what happens when numbers team up, when they combine. We're going to be putting numbers together. That's what addition is. Let's say you have 3 strawberries. Very cool, very tasty, and someone offers you another strawberry. So you add that strawberry to your collection. 3 strawberries plus 1. This plus sign tells us we're doing addition. What's 3 plus 1? Yeah, 4. The number 3 plus 1 is 4. We're just putting numbers together. Okay, I have 1 carrot and I get another carrot. 1 plus 1. How many carrots do I have now? Yeah, 2. 1 plus 1 is 2. I have 2 carrots now. All right, let's say I have 5 carrots. And someone offers me more, but I politely say, no thank you, I have enough. So I had 5, and we're adding no more carrots. 0 carrots. 5 plus 0. What is 5 plus 0? Yeah, 5. If you add 0 to a number, the number doesn't change. You're adding nothing. Great job. Let's look at one more basic addition example. Let's say I'm going grocery shopping. How exciting! I put 3 bananas in the cart. There are 3 things in the cart. The 3 bananas. I love bananas. And I put 3 lemons in the cart too. Hey, everything in the shopping cart is yellow. That's pretty cool. Let's add these numbers together to see how many things are in our shopping cart so far. What's 3 plus 3? 3 plus 3. Yeah, 6. Awesome job. We can double check that by counting them. 1, 2, 3, 4, 5, 6. 3 plus 3 equals 6. I have 6 things in my shopping cart. These are examples of single-digit addition. But what if we need to add bigger numbers? Let's say there's this kid named Travis. Hi, Travis. Travis collects these. What are these called? Marbles. Travis collects marbles. Travis had a lot of marbles. He had 54 marbles. But today's his birthday, and someone just gave him 21 more marbles. Wow! And now he wants to know, how many marbles do I have? I had 54, and now I have 21 more that are in my collection. How many marbles do I have? That's the question that Travis has. What's 54 plus 21? Now here's the deal, Travis. You could count each of the marbles one by one to figure out exactly how many you have now. But that would take a long time. Look at all of these marbles. There has to be a better way. In fact, there is. There's a way that is super fast and super fun. We can add 54 and 21 together by doing a fun trick. We'll turn these big numbers that are difficult to add on their own into smaller numbers. What you will do is you will add the numbers to the right here, which are the ones. To make it easier, we are going to block the 10 spot for right now with this nifty blue rectangle. Suddenly, this huge big addition problem has turned into a simple, fun addition game. So we add the right spot, the ones spot together. What is 4 plus 1? Yes, 4 plus 1 equals 5. So we'll write 5 under the 4 and the 1. Awesome job. We're halfway done already. Next, we will add the 10s together. The 10 spot is to the left. The two numbers in the 10 spot are the 5 and 2. To make it easier, we are going to block the 1 spot with another blue rectangle because we already added the 1 spot up. What is 5 plus 2? 5 plus 2 equals 7. So we will write 7 under the 5 and the 2. So what is our answer? What is 54 plus 21? You can see it right here. 75. 54 plus 21 equals 75. The answer to an addition problem is called the sum. Our sum is 75. It's simple. With double-digit addition, you add the right side, the ones, together first. Let's figure out what 30 plus 12 is. First, what is 0 plus 2? Yes, 0 plus 2 is 2. So we'll write a 2 under the right side, the ones side. We've almost arrived at our answer already. Then we add the left side, the 10s, to get our answer. What is 1 plus 3? Yep, 1 plus 3 equals 4. So the sum of this addition problem is 42. 30 plus 12 equals 42. Let's try a different type of addition problem. 33 plus 6. This is an interesting one because 33 is a double-digit number, but the number 6 is a single-digit number. But we use the same fun trick as before. First, we add up the ones. What is 3 plus 6? 3 plus 6 equals 9. So we write 9 here under the ones. Next, let's add up the 10s. But there is only one number in the 10 spot. So what do you get if you add nothing to 3? You get 3. So what is our sum? Yes, our sum is 39. How are we doing? Double-digit addition is pretty cool, isn't it? Now we are going to talk about something special, really special. Special like seeing an owlet, a little baby owl looking at you, looking at your eyes, you know. So cute, so cute, so special. So what is this special thing we are about to learn? Well, sometimes something sneaky happens. Let's show you. Let's say we are adding 17 plus 15. We of course start with the right side, adding up the ones first. So what is 7 plus 5? Do you know? 7 plus 5. Yeah, 7 plus 5 equals 12. That's right. But there's only enough room for one digit under the 7 and the 5. So what do? Well, we do a super cool move called regrouping. Regrouping is awesome. Remember, the sum of our ones column is 12. 7 plus 5 equals 12. So we have to regroup the number 12. But what does that mean? What does regrouping even do? Well, regrouping splits the digits and puts them in different places. Now that might sound weird, but we're going to show you how it works. It's super simple and fun. Regrouping the number 12 is easy. All we do is split the digits, putting the 2 under the 1s and carrying the 1 with the 10s up here. That's it. Then we add up the 10s. What is 1 plus 1 plus 1? Yeah, 1 plus 1 plus 1 equals 3. So we write 3 under the 10s. And now we have our answer. 17 plus 15 equals 32. 32 is our sum. Remember, regrouping is only used when there is a double-digit number, but there is only space for one digit, like our example, 7 plus 5 equals 12. But there wasn't enough room for both numbers, so we keep the 2 under the 1s and carry the 1 to the 10s. Hey, let's practice by playing a game. The game is called Do We Need to Regroup? This is probably the most exciting double-digit addition game ever. Hosted by our very own Mr. Whiskers. Thanks for helping us out. You're not gonna help us out. Okay. Okay, now this is embarrassing. Okay. Fine. Okay. Alright. That's okay. That's alright. It's alright. Okay. It's okay. Alright, well, we are going to look at double-digit addition problems, and you are going to let us know, do we need to regroup? Here is our first problem, 32 plus 19. You already know the question. When we add 32 and 19, do we need to regroup? Yes, because 2 plus 9 equals 11, which is a double-digit number. Remember, the first step we take is adding up the ones. But if the sum is a double-digit number, that means we need to regroup. Great job. Let's go ahead and finish the problem. When we regroup, we split the digits. So the first 1 gets carried, and the second number, in this case, also the number 1, stays down under the 1s. Then we just add up the 10s. What is 1 plus 3 plus 1? 5. So, 32 plus 19 equals 51. And yes, we did have to regroup. Here is our second one, 56 plus 22. This is the question. When we add 56 and 22, do we need to regroup? No, because 6 plus 2 equals 8, and 8 is a single-digit number that can fit under the 1s. Remember, the first step we take is adding up the 1s, and since the sum is a single-digit number already, we do not need to regroup. Fantastic. Let's go ahead and finish the problem. So when we added up the 1s, our sum was 8. We'll put the 8 under the 1s. Then we just add up the 10s. What is 5 plus 2? 7. And we have our answer. 56 plus 22 equals 78. And no, we did not have to regroup. Here is our next one, 34 plus 25. This is the question. When we add 34 and 25, do we need to regroup? The answer is no, because 4 plus 5 equals 9, and 9 is a single-digit number that can fit under the 1s. Remember, the first step we take is adding up the 1s, and since the sum is a single-digit number already, we do not need to regroup. Well done. Let's go ahead and finish the problem just for fun. So when we added up the ones, our sum was 9. We'll put the 9 under the ones. Then we just add up the tens. What is 3 plus 2? 5. And we have our answer. 34 plus 25 equals 59. And no, we did not have to regroup. This is our last one. You have been doing great. 43 plus 37. You already know the question. When we add 43 and 37, do we need to regroup? Yes, because 3 plus 7 equals 10, which is a double-digit number. Remember, the first step we take is adding up the ones, but if the sum is a double-digit number, that means we need to regroup. Wonderful. Let's go ahead and finish the problem. When we regroup, we split the digits. So the number 1 gets carried, and the second number, in this case, the number 0, stays down under the ones. Then we just add up the tens. What is 1 plus 4 plus 3? 8. So 43 plus 37 equals 80. And yes, we did have to regroup. Whoa, you sure did a great job. Nice work. We reviewed basic addition and then learned about double-digit addition. That was pretty awesome. It can be a little tricky, especially with regrouping, but with lots of practice, you'll be a pro in no time. I think you're ready for the next topic, okay? Now it's time to look at subtraction. Yeah, subtraction. We'll review basic subtraction first, and then we'll explore double-digit subtraction. Oh, it's time to do subtraction. Now, subtracting is just taking numbers away. How many dogs do you see? Yeah, 3. But one dog leaves. He has something else going on right now. How many are left? Yeah, 2. There were 3 dogs and 1 left. 3 minus 1. This minus sign is what we use when we subtract. How many were left? Yeah, 2 dogs were left. 3 minus 1 equals 2. That's subtraction. Or let's say you have 2 carrots, which is great. Carrots are absolutely amazing. And you give 1 carrot to a bunny, for her birthday. We'll need to subtract 1 carrot from the 2. What is 2 minus 1? Yeah, 1. You would have 1 carrot left. 2 minus 1 equals 1. Oh, we're in a bakery. How cool is that? There are so many baked goodies here, and plenty of customers are here to buy them. Let's say the bakery had 5 of these pies, and they sold 2 of them. To find out how many are left, we have to figure out what is 5 minus 2. What's 5 minus 2? Yeah, 3. Great job! So there were 5, and then 2 of them were sold. After we subtract 2, 3 are left. 5 minus 2 equals 3. That's basic subtraction. But now we want to look at bigger numbers, double-digit numbers. Let's say we have a lot of blueberries. For some reason, they're just hanging out on a wooden table. We need to wash them and put them in a bowl. Let's pretend that when we were putting them in the bowl, we counted them and found that we had 66 blueberries. That's a lot of blueberries. You and your friends are hungry and blueberries are super yummy, right? So you and your friends eat 54 blueberries. That's right. These are some big numbers, some double-digit numbers. To find out how many blueberries we have left, we simply subtract 54 from 66. Let's look at how that's done. Here is our subtraction problem again, 66 minus 54. With double-digit subtraction, all we do is break this big problem up into two little problems. First, we will subtract the right column, the ones. To make it a little easier, we are going to cover the tens column with this blue rectangle. Suddenly, this big subtraction problem is a really easy one. What is 6 minus 4? Do you know? Yes, 6 minus 4 equals 2. So we put the number 2 under the ones column, the right side. Great job. We are halfway to our answer. Next, we will subtract the left column, the tens. And this time we're going to cover up the ones column to make it a little easier. So, what is 6 minus 5? 6 minus 5. 6 minus 5 equals 1. We will write 1 under the tens, the left column. And just like that, we have our answer. The difference is 12. There are now just 12 blueberries. All right, let's do another one. How about 87 minus 53? This should be fun. First, subtract the right side, the ones. What is 7 minus 3? Yes, 4. So we will write 4 under the ones. Simple. Next, we just subtract the left side, the tens. What is 8 minus 5? Yes, 3. So we write 3 under the tens column. And we have our answer. The difference is 34. Double-digit subtraction is simple. First, subtract the right, the ones. Next, subtract the left, the tens. Then you have your answer, which is also called the difference. Now, there is something interesting that can happen when you subtract larger numbers. Here, we'll show you. Say we have this subtraction problem, 22 minus 17. Let's follow the process. So first, we subtract the ones. What is 2 minus 7? Well, here's that interesting thing we mentioned to you. Say I have 2 carrots, and I need to give 7 carrots away. That's a problem. It's hard to give away more than you have. So what do? Well, we do a special trick. No, not this kind of trick. Wow, he is really high up there. No, not this kind of trick either, alright? It's a math trick, okay? It's a math trick. This is a subtraction video after all. The trick is called regrouping. Can you say that? Regrouping. Yeah, regrouping. When you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. Just like in this example, because it is hard to take away more than you have, and 7 is bigger than 2, so we need to regroup. So how does this regrouping trick work? It's really easy. All you do is borrow 1 from the tens column. What is 2 minus 1? Yeah, 1. So this number in the tens column becomes a 1. And that 1 that we borrowed from the tens, it goes to the ones. It gets placed on this 2 in the ones column. And now the ones column is 12 minus 7. Now we just have to follow our subtraction game plan. We subtract the right column, the ones first. What is 12 minus 7? Yes, 12 minus 7 equals 5. So we write the number 5 under the ones column. Then, of course, we have to subtract the tens, but regrouping made this super easy. What is 1 minus 1? Yes, 1 minus 1 equals 0. So our answer is simply 5. 5 is our difference. Remember, when you are subtracting a column and the bottom number is bigger than the top number, that means you need to regroup. And with subtraction, regrouping means borrowing. In double-digit subtraction, regrouping is when you borrow 1 from the tens column. Let's try one more double-digit subtraction problem and see if we need to use the special regrouping trick. 43 minus 25. This is going to be awesome. Remember, the first thing we do is subtract the right column, the ones. But, 5, the bottom digit, is bigger than 3, the top digit. Time to regroup. So we borrow 1 from the tens column. What is 4 minus 1? Yes, 3. Then we put that 1 in front of the 3 in the ones column, making it the number 13. Then we just follow the process, subtracting the ones column first. What is 13 minus 5? What is 13 minus 5? Yep. It is 8, so we will write 8 under the ones column. Now it's time to subtract the tens. What is 3 minus 2? What is 3 minus 2? You got it. 3 minus 2 equals 1. So we put the number 1 under the tens column, and we have our answer. 43 minus 25 equals 18. 18 is the difference. We've learned a lot, but we need to make sure we are able to remember everything. Here's an idea. There's this guy, Mummy, who doesn't know how to do double-digit subtraction, okay? So we are going to do a double-digit subtraction review by teaching Mummy. It's simple and it's fun, Mummy. You'll love it. So, Mummy, subtraction is when you take numbers away. Sometimes subtraction problems can have little numbers, or other times subtraction problems can have bigger numbers, double-digit numbers. Here's how it works, Mummy. First, subtract the right column, the ones. Next, you subtract the left column, the tens. Then you have your answer, which is called the difference. Sometimes the bottom digit is bigger than the top digit in the ones column. This is something to get excited about, Mummy. It means you can use a special trick called regrouping. You just borrow 1 from the tens column and move it to the ones column. Then just follow the plan. Great job with double-digit subtraction. Oh my goodness, you did an amazing job. I think it's time to learn about clocks and how to read them. Clocks are amazing, wonderful inventions. Humans have used clocks for a really long time. In the ancient world, a common type of clock was the sundial. That's right, the sundial. Sundials are very accurate, but are not used often today. Have you ever asked what time it is and someone checks their sundial? Yeah, that isn't real common. Today, most clocks are digital clocks. Digital clocks are really simple to use. They simply show the digits for the hour and minutes. So here we have a digital clock. Here on the left, we see the hour. It is 7. On the right, we see the minutes, 10. So what time is it according to this clock? Yeah, it is 7:10, 10 minutes past 7 o'clock. What about this clock? Here is another digital clock. What time is it according to this clock? Yes, it is 10 o'clock. On the left, we see the hour, which is 10. And on the right, we see the minutes, which are just zeros. So it is exactly 10 o'clock. Now, digital clocks are not the only way we can see what time it is. Have you ever seen a clock like this before? Yeah, this is called an analog clock. It is a different way to display time. In this video, we are going to learn how to read analog clocks, which will be super awesome because there are analog clocks all around us that want to be read. They want to show us the time. So, to start, we are going to learn some fun things about the analog clock. The front is called the face of the clock, or the dial. Just like you have a face, an analog clock has a face. That's right. The face includes the numbers, the parts that spin, and all the markings on the clock. The face, sometimes called the dial, has two main parts that point to the numbers and spin around. They are called hands. Isn't that interesting? The shorter hand is the hour hand. It shows us what hour it is. The hour hand is short. The longer hand is the minute hand. It points to the minutes. It's silly, even though an hour is longer than a minute, the hour hand is shorter. The hour hand is the short hand, and the minute hand is the long hand. So just like you, analog clocks have a face and usually have two hands. The short hand points to the hour. The long hand points to the minutes. Let's go back to our analog clock and see if we can figure out what time it is showing. Just like we do with the digital clock, let's look at the hour hand, the short hand first. What number is it pointing at? Yes, at the number 3. Great. So it is the third hour. It is 3 something. Now we just have to read the minutes. The minute hand is the long hand. But how do we read the minutes? It only goes up to 12, and those big numbers are what we use for the hours. What do we do? Mr. Whiskers, we're recording. What? You know how to read the minutes on an analog clock? I didn't even know you knew how to tell time. You're a cat. You have a trick? Well, we should hear the trick. It's important for us to learn how to do this. Okay, an analog trick with Mr. Whiskers. Okay, that's a little crazy, but that's okay. All right, so what's the trick? Oh, okay, so we need to count by 5s to find out the minutes. That's a wonderful trick. That's amazing. You see, all of those little lines in between the numbers on the face of the clock represent 1 minute. To find out the minutes, we just have to count by 5s around the clock, starting at the 12. The 12 is like the starting line. When the minute hand is at the 12, that means 0 minutes. Then the 1 is 5, 2 is 10, then 15, 20, 25, 30, 35, 40, 45, 50, 55, and then back to 0. All we have to do is count by 5s. Okay, so we're ready to figure out what time this is. Okay, so we already know what the hour is. The hour is 3. Yes. Okay, so we write 3. Now we have to figure out the minutes, and the minute hand is pointing at the 12, which means what? How many minutes? 0. Yeah, and with minutes, we always write 2 digits, so we'll write 2 zeros. What is this time? Yeah, 3 o'clock. Great job! Okay, let's try this one. What time does this clock say? Where's the hour hand? Yeah, on the 5. And where's the minute hand? Yep, at the 12. So you know there are zeros at the end of that. What time is it? Yes, it's 5 o'clock. Great job. All right, let's try this one. Okay, both hands are pointing at which number? Yeah, 12. What time is this? Yes, 12 o'clock. Great job. Notice if the minute hand is pointing at the 12, you always say o'clock. So this is 12 o'clock, just like before we had 3 o'clock and 5 o'clock. This is 12 o'clock. Terrific. Now we are going to change things up. Just remember our trick, count by 5s, okay? Let's figure out what time this clock is showing us. First, let's look at the hour hand. Wait, it isn't directly pointing at a number, it is between the 2 and the 3. No worries. When the hour hand is between two numbers, the hour is the earlier number. So the hour is 2. Where is the minute hand pointing? That's right, at the number 6. We are going to use Mr. Whisker's trick and count by 5s. We start at the 12, which is 0. Then we count 5, 10, 15, 20, 25, 30. So how many minutes is this showing? 30. That's right. So what time is the clock showing? 2:30. You got it. This one looks like fun. What time is it according to this clock? First, let's look at the hour hand. The hour hand is between numbers again. It is between which numbers? Yes, 8 and 9. Remember, when the hour hand is between two numbers, the hour is the earlier number. So the hour is 8. Where is the minute hand pointing? That's right, at the number 3. We are going to use Mr. Whisker's trick and count by 5s. We start at the 12, which is 0. Then we count 5, 10, 15. So how many minutes is this showing? 15, yeah! So what time is the clock showing? 8:15, you got it! How about this one? What time is it according to this clock? First, let's look at the hour hand. The hour hand is between numbers again. It is between which numbers? Yes, 11 and 12. Remember, when the hour hand is between two numbers, the hour is the earlier number. So the hour is what? 11! You are right! Okay, so where is the minute hand pointing? Yep, at the number 9. We are going to use Mr. Whisker's trick and count by 5s. We start with 12, which is 0, then we count 5, 10, 15, 20, 25, 30, 35, 40, 45. So how many minutes is this showing? 45, you got it. So what time is this clock showing? 11:45. Yes, great job. We looked at examples of when the hour hand isn't pointing directly at a number on the face of a clock. You know, sometimes the minute hand isn't pointing directly at a number. Look at this example. The hour hand is between which two numbers? Yes, 7 and 8. Which number is the hour? Yep, 7. The hour is always the earlier number on the clock when it is between two numbers. Now the minute hand is near the 8, but notice it went past the 8 by 2. To figure out the minutes, we will count by 5s just like before, and then add 2 at the end. The 12 is 0, 5, 10, 15, 20, 25, 30, 35, 40. Then you just add 40 plus 2. You gotta add 2. What is 40 plus 2? Yeah, 42. So the time is 7:42. Wonderful job, that's great. Let's look at one last analog clock. Just looking at this clock, what is the hour? Yes, 12. Because 12 is the earlier hour on the clock. How about the minutes? Use the count by 5s trick and notice the minute hand is 1 minute after the 4. You'll need to add 1 minute. All right, 21. So the time is 12:21. Let's check the minutes to be sure. 5, 10, 15, 20, then add 1, which is 21. You have done a great job. Before we conclude this video, we want to share two more things. What's with the swans? We are sharing two things about analog clocks. We aren't sharing two swans. Okay, so first, analog clocks sometimes use Roman numerals instead of regular numbers. Fancy clocks and clock towers usually use Roman numerals. If you need help with Roman numerals, we do have a video about that. The second thing is that you may see a thin hand, sometimes a different color than the hour and minute hands, that shows the seconds. It isn't always there, and it doesn't help you tell the time. It just shows how fast time is moving. The second hand moves really fast. To tell time, we use the two main hands, the hour hand and the minute hand. We learned that the front of an analog clock is called the face, or the dial. The pointers on the face of the clock are called hands. The short hand shows us the hour. If the hour hand is between two numbers, the hour is the earlier hour on the clock. The long hand shows us the minutes. To find the minutes, we count by fives along the face of the clock until we reach where the minute hand is pointing. Sometimes we need to add a few minutes because the minute hand isn't always pointing directly at a number. It can take some practice, but I hope this helped you learn how to read analog clocks. So no matter what type of clock you are near, you will be able to read the time. Unless that clock is a sundial, okay? You did an awesome job. In fact, this whole video you have been doing great. You are building some wonderful math skills. You really are. I think you're ready, okay? Next, we are going to learn about patterns. That's right. Patterns, they are all around us. You can see patterns in buildings, patterns are used in clothing and design, and patterns are everywhere in math. Just look at the numbers on this ruler, the lines on this ruler, the lines on the paper. You might be wondering, what do patterns do? Well, patterns do the same things over and over again. Patterns repeat. Now this is super cool. Every pattern follows a special rule. The rule is how the pattern works. We'll give you an example. Look at this pattern. It begins with a red rectangle followed by a yellow rectangle. Next is a red rectangle and another yellow rectangle. Next is a red rectangle followed by another yellow rectangle. It's doing the same thing over and over again, so it is definitely a pattern. What special rule does this pattern follow? Well, rectangles alternate between red and yellow. Do you see that? The rule tells us how the pattern works. In this pattern, rectangles alternate between red and yellow. So remember, every pattern follows a special rule. The rule is how the pattern works. If you figure out the rule, you've cracked the pattern's code. Even if there is a part of the pattern missing, you will be able to find it because you cracked the code. Here's the pattern we just showed you. Imagine this spot missing. What belongs in this spot? Well, let's think of this pattern's rule. Rectangles alternate between red and yellow. So what color rectangle goes here? Yeah, a red rectangle. By figuring out the rule, we were able to fill this spot in the pattern. Alright, we have another pattern here. Instead of shapes, we have numbers in this pattern. The first thing we need to do is find out what makes this a pattern. Look at each of the numbers and see if you can see a pattern. What rule does this pattern follow? Do you know? Yeah, you always add 1 to get the next number. Every number goes up by 1 each time. That's the pattern. Great job! Okay, now we are going to play a game called Complete the Pattern. We'll show you a pattern, and then you can try to crack the code and complete it. Here's the first one. You'll notice there are a lot of shapes here, so we should probably just look at this pattern line by line and see what we discover. On this first line, we see a green circle, a blue square, and a green circle. It's almost like a blue square sandwich. The second line is similar to the first, except there are 2 squares in between the green circles instead of just one. This third line is just like the second line, except there are 3 blue squares in between the green circles instead of 2. Notice a pattern? So let's complete this pattern. How many blue squares are in this fourth line? Yeah, 4. The fourth line has 4 blue squares in between the green circles. How can we know that? Well, the blue squares increase by 1 each line. The blue squares in between the green circles keep growing by 1 every line. That's how this pattern works. Great job. All right, Andy, really? He does this every afternoon. It's a pattern for him. Every afternoon he dances near the woods. We are playing Complete the Pattern, Andy. We don't have time for these super cool dance moves. They are pretty cool. Okay, they are. Oh, goodness. Kevin, I know you dance every afternoon as well. That's a pattern for you, too. But, Kevin, we really do have to get back to our game, okay? Come on. All right, if there are no more interruptions, all right, let's look at this next pattern. Oh, goodness, look at this series of creatures, these animals. The first is an interesting-looking hamster, followed by 2 birds. Then there's a hamster, and then there's a mystery spot that we have to complete, and a bird, and then the hamster, and then 2 birds. That's pretty cool. Let's complete this pattern. Just by looking at this pattern, what do you think goes in this spot? Yeah, a bird. A bird goes here. Now, how do we know that a bird goes here? Well, to crack the code and figure out the pattern, we have to look at the clues. We see a hamster first, followed by 2 birds. Then another hamster and 2 birds, and it goes on and on. The rule for this pattern, then, is that a hamster is followed by 2 birds, and then the pattern repeats. Patterns repeat. Andy, please. Okay, the kids are learning, please. All right, patterns repeat. I was kind of waiting for Kevin. Okay, I guess he isn't going to interrupt him. Kind of impressed. Oh, never mind. Never mind. Apparently I spoke too soon. All right, Kevin, we really do have a final pattern to look at, okay? I think we're ready. Here is the final pattern for us to complete. Is this a pattern with shapes or numbers? Yeah, numbers. We need to figure out what the final number is in this pattern. Look at the different numbers and see what pattern you notice. Once you figure out what rule these numbers are following, you'll be able to figure out this last number. What is this missing number in the pattern? Yep, 4. Great job. How do we know that this missing number is the number 4? Well, what rule did you notice the pattern was following? Yes, subtract 1 to get the next number. So the first number is 9, and the next number is 1 less than 9, 8. Then you subtract 1 to get 7. You subtract 1 to get 6. You subtract 1 to get 5. And finally, you subtract 1 from 5 to get our answer, 4. Okay, it's official. You are awesome at patterns. It's true. It's true. Patterns are so much fun. When you see a pattern, you can try to figure out what rule it is following. Patterns are all around us, just waiting to be discovered. All right, patterns. They are so cool. And so are you. You are doing an amazing job. Next, we are going to learn about something really cool called place values. Place values. But to do that, we need to learn this word right here. Digits. Digits. So, what are digits? Digits are the parts of a number. Like, look at the number 920. There are 3 parts, or digits, in this number. The number 920 has 3 digits. Remember, digits are the parts of a number. Pretty simple. Let's look at the number 74. There are 2 parts, or digits, in the number 74. The number 74 has 2 digits. Remember, digits are the parts of a number. Super simple, super easy. And finally, let's look at the number 6. How many digits are in the number 6? Remember, we're just looking at the parts of the number. How many digits? Yeah, just 1 digit. There's only 1 part or digit to this number. It's just 6. Great job! Remember, digits are the parts of a number. Okay, so this is awesome. Here is where place values come in. The place value is how much a digit is worth based on where it is. In other words, where a digit is in the number tells us how much it is worth. So, what are the place values we're going to be looking at today? What are the different values of the places where the digits will be? Well, the digits will either be in the ones spot, the tens spot, the hundreds spot, or the thousands spot. Alright, let's use the place values. Okay, so here are the place values and where they are for the different digits. This first spot is the ones spot. That's where the ones go. This second spot is the tens spot. It's where the tens go. This third spot is the hundred spot. It is where the hundreds go. And finally, here is the thousands spot. It is where the thousands go. Now the place values can go higher than this, but these are the only place values we're going to be learning about today. Alright, so our first example is the number 4,000. The number 4,000. Alright, well I'm going to need your help. Which digit is in the ones spot? You can see it right there. Which digit is in the ones spot? Yeah! 0! Great job! Alright, how about helping us figure out the tens? Which digit is in the tens spot? Yeah! 0! Good job! All you have to do is look where the arrow is pointing. The 10 spot is a 0. Alright, how about the hundreds spot? Which digit is in the hundreds spot? You see? Yeah, the same answer, 0. Good job, good job. Okay, and which digit is in the thousands spot? Which digit is in the thousands spot? Yeah! 4! Awesome! The number 4 is in the thousands spot. There are 4 thousands in the number 4,000. Alright, our next example is the number 508. Okay, I'm gonna need your help again. Which digit is in the ones spot? You can look at the place values for a clue. You can see the arrow. Which digit is in the one spot? Yeah, 8. Good job. Okay, which digit is in the tens spot? Which digit is in the 10 spot? Yeah, 0. Good job. Alright, which digit is in the hundreds spot? Can you see that? Which number is in the hundreds spot? Yeah, 5. Good job. Okay, now this might seem a little tricky. Which digit is in the thousands spot? Which digit is in the thousands spot? Wait a second, there isn't even a digit there. It's only 508. There are no thousands. So the digit would be nothing or 0. 0 and nothing, it has the same value. So there's nothing that's in the thousands spot. It's only 508. There are no thousands. You are doing a phenomenal job. Okay, now you're going to be able to give it a try without any help or any clues. And you've learned so much. I think you can do it. I think you can do it. You're going to do awesome. Okay, you're ready. Here's the number. 8,763. 8,763. We're going to name the place values, and you let us know which digit is in which one. Okay, which digit is in the 1 spot? Which digit is in the 1 spot? The number's 8,763. Which one? Yeah, 3. 3 is in the 1 spot. Remember, this is the 1 spot. Good job. Okay, what's in the 10 spot? Which digit is in the 10 spot? 6. 6 is in the 10 spot. Good job. Yeah, you can see right here is where the 10 spot is. Wow, you're getting the hang of it. Okay, which digit is in the 100 spot? Do you know which one? Which digit is in the 100 spot? 7. Way to go. Yes, 7 is in the 100 spot, and you can see right here is that 100 spot. Yeah, 7 is in the 100 spot. Good job. Okay, here's the last one. Which digit is in the thousands spot? Which digit is in the thousands spot? 8. Yes, good job. 8 is in the thousands spot. And you can see right here is where that thousands spot is, just before that comma. Isn't that awesome? Wow, you've learned so much. To review, digits are the parts of a number. The place value is how much a digit is worth based on where it is. These are the place values we learned today, the ones, tens, hundreds, and thousands. In this example, there are 3 ones, there are 6 tens, which is 60, there are 7 hundreds, which is 700, and there's 8 thousands. So the number read out is 8,763. It's so nice going for a stroll and just thinking about those place values. Oh, I love the ones and the tens and the hundreds and the thousands. Knowing where a digit is tells us what the value is, which is great. Place values. Wow, they are super fun. Speaking of fun, I think the next thing we should learn about should be coins. Yeah, the U.S. coins. The first thing I want to share about coins is this. Did you know there are 6 types of U.S. coins? We're going to look at each of the types individually so that no matter what coin somebody shows you, you'll know what kind of coin that is and how much it's worth. We're going to look at the penny, the nickel, the dime, the quarter, the half dollar, and even the dollar coins. Alright, let's fly into our lesson! The first coin is the penny. So what is a penny? Well, the penny is a copper coin with Abraham Lincoln's face on it. Traditionally, pennies feature the Lincoln Memorial on the back. Remember, the Lincoln Memorial is a memorial in honor of Abraham Lincoln. In 2010, they changed the penny to feature the Union Shield on the back instead of the Lincoln Memorial. So, if a penny has the Union Shield on the back, you know it's a newer penny. The penny is worth less than all the other coins. It is worth 1 cent, which is easy to remember, especially if you're looking at the penny, because on the back of the penny, whether it's an old penny with the Lincoln Memorial or a new penny with the Union Shield, it actually says 1 cent on the back of the coin. A penny is worth 1 cent. This is pretty weird. Did you know some people don't like the penny very much and they think we should get rid of the penny? In fact, it costs more to make a penny than it's even worth. So some people say, hey, we're losing money with making these pennies. Maybe we should get rid of the penny. As of today, it costs 1.67 cents to make a penny. That's actually less than it used to be. It used to cost 2 cents or 2 pennies just to make 1 penny. Even though some people want to get rid of the penny looks like it's here to stay. Ah, the penny. What a wonderful coin. It's got Abraham Lincoln on the front. Older pennies have the Lincoln Memorial, and newer pennies have the Union Shield on the back. They're worth 1 cent, so they're not worth much, but who hasn't gotten excited finding a nice new shiny penny? Cool! The second coin is the nickel. The nickel is a coin made of both copper and nickel that has Thomas Jefferson on it. Like the penny, the nickel has gone through a change in recent years. It doesn't look the way it has always looked. Traditionally, nickels feature the side of Thomas Jefferson's face. But in 2006, the nickel was changed to show the front of Thomas Jefferson's face instead of just the side. Old nickel, new nickel. Old nickel, new nickel. Old nickel, new nickel. Okay, you get the idea. Unlike the front of the nickel, the back of the nickel has stayed the same through the years. It features Monticello, which was Thomas Jefferson's house. A nickel is worth 5 cents, which is the same as 5 pennies. Because remember, a penny is worth 1 cent. So a nickel, being worth 5 cents, is worth the same as 5 pennies. The nickel, it's a coin that's the color silver, it's got a house on the back, which is Monticello, and depending on how old the nickel is, it either just shows the side of Thomas Jefferson's face or the front of Thomas Jefferson's face, and it's worth 5 cents. Awesome! Well, the third coin is the dime. The dime is a silver-colored coin made of both copper and nickel that has President Franklin D. Roosevelt on it. This is pretty interesting. The dime is the smallest size coin, but don't let the size trick you. It's worth more than the nickel and the penny combined. A dime, how much is it worth? Well, a dime is worth 10 cents, which is the same as 10 pennies. Wow, what's easier to carry around? A little dime that's worth 10 cents or 10 pennies? Oh my goodness. The dime, a really small silver-colored coin with President Franklin D. Roosevelt on the front, and on the back, a torch. It's the same as 10 pennies, but it's a lot easier to carry around. At least, I would think, right? The dime. Pretty cool. Alright, the fourth coin is the quarter. Alright, well, what is a quarter like? Well, the quarter is a silver-colored coin made of both copper and nickel that has George Washington on it. And yeah, it's a much bigger-sized coin than the dime, that's for sure. The back of a regular quarter has a bald eagle on it. And we say a regular quarter because there are so many quarters that aren't just regular quarters. It's kind of an interesting coin that way. Quarters are cool coins because there are 3 special quarter collections. The state quarters that have states on the back, the territory quarters that have territories on the back, and America the Beautiful quarters that have different scenes from the United States of America on the back. Here's a fun hint. Even if the back looks different, if it is a silver-colored coin with George Washington on it, it is a quarter. You might be wondering, how much is a quarter worth? Well, a quarter is worth 25 cents, which is the same as 25 pennies, because remember, pennies are worth 1 cent. So imagine what's easier, carrying around 1 quarter or 25 pennies, right? Oh my goodness, quarters are awesome. The quarter is a large silver-colored coin with George Washington on the front and a bald eagle on the back. But be careful, there are lots of special edition quarters like state quarters, territory quarters, and America the Beautiful quarters. Just follow our hints and look at the front of the coin to find out if it is a quarter. And remember, the quarter is worth 25 cents, which is the same as 25 pennies. Alright, are you ready for the 5th one? I can't hear you, come on. Okay, alright. The 5th coin is the $50. Well, what's the $50 like? The $50 is a silver-colored coin made of both copper and nickel that has President John F. Kennedy on it. The back of the $50 features the presidential seal surrounded by 50 stars. What do you think the 50 stars represent? Do you have an idea? Yeah, the 50 states of the United States of America. And remember, there's a bald eagle on the back of a quarter too. But on the $50, that bald eagle, which is part of the presidential seal, is surrounded by stars. So if it's surrounded by stars, you know it's a $50. Plus, the back of the coin says $50, so that makes it easy too. You can look high and low for $50, but they're pretty rare. In fact, you might not see one for a really long time. One thing you can do is you could go to the bank and take 2 quarters with you. When you take those 2 quarters, you can ask if they have any $50, and you can trade 2 quarters for $1 $50. They still make $50, but as we said, they're more rare than the quarters, the dimes, the nickels, and the pennies. You might have figured this out already, but it is called a $50 because you only need 2 to have a dollar. It only takes 2. If you have 2 $50, then you have 1 whole dollar. Well, if that's true, how much is a $50 worth? Well, the $50 is worth 50 cents. That's the same as 50 pennies. Whoa! This coin is worth a lot. The $50, pretty awesome coin. It's silver colored and has President John F. Kennedy On the front, on the back is the presidential seal surrounded by stars, and it's worth 50 cents. Oh my goodness, you only need 2 of these coins to have a whole dollar, but I wouldn't trade 2 of them for $1 because they are rare, and when you find a half dollar, oh my goodness, that's such a treasure. It's so cool because they are rare and they are limited, but oh my goodness, I just love the half dollars. The half dollars are awesome. The final coins are the dollar coins. There are 2 main dollar coins. There's the Sacagawea dollar, and there are the presidential dollars. We're going to look at both of those right now. The Sacagawea dollar, also known as the golden dollar, honors the extraordinary Native American woman who helped Lewis and Clark in their expedition out west. The back of the Sacagawea dollar features a bald eagle in flight. What's with these bald eagle coins? It's just an American bird, right? The bald eagle. And so this is another bald eagle coin, but it's golden color. That's why the coin is called the golden dollar. So if you see a golden coin with an eagle on the back, it's a Sacagawea dollar. And finally, the presidential dollars, which celebrate the first 40 presidents of the United States, all the way up to Ronald Reagan. From George Washington to Ronald Reagan. Here's one with Gerald Ford on it. Really cool collectible coins that feature the first 40 presidents. Well, what does the back look like? Well, the back of the presidential dollars feature the Statue of Liberty. Really cool. And they all say $1 on the back, which makes sense because they are dollar coins. The dollar coins. There's 2 types, right? The Sacagawea dollar, also known as the golden dollar, and the presidential dollars. These are wonderful coins that look really cool. People actually didn't like even buying stuff with them. They just wanted to collect them. But these dollar coins are really neat. You might see one and wonder, what kind of coin is this? And then you'll remember this video and say, hey, this is a dollar coin. Wow, I am so proud of you. You did an amazing job learning about the U.S. coins. This has been an incredible math adventure, but it's almost done. There's just one more topic to learn about. Are you ready? Okay, next, we're going to learn about symmetry. Symmetry, yeah. If you don't know what that is, that's okay. You are about to find out, like right now, all right? Look at this triangle. It's a yellow triangle with a red border. Sometimes warning signs on the road look like this. To show you how symmetry works, I'm going to place this line down the middle of this triangle. Okay, it's still one triangle, but now it has 2 sides. Do you notice anything about the 2 sides of this triangle? Both sides match each other perfectly, don't they? That's pretty neat. And that's actually what symmetry is. This line is called a line of symmetry. A line of symmetry. If you were to draw this line down the middle of this shape, both sides would match. Aw, look at this butterfly. Does this picture of a butterfly have symmetry? Yeah. If we place a line down the middle of this picture of a butterfly, you can see both sides match each other. Yes, this line is called, do you remember? A line of symmetry. Yeah, a line of symmetry. We know it's a line of symmetry because both sides match each other. Actually, butterflies are symmetrical in real life. The patterns on both of their wings are identical to each other. They match. Butterflies are symmetrical. Let's check out some of the letters and see which ones have symmetry. We can try the first letter, the letter A. Does the capital letter A have symmetry? Yeah, it does. The capital letter A has one vertical line of symmetry, right here. Now, how do we know that's a line of symmetry? Well, we look at both sides. Do both sides match? Yes, great job. both sides match each other. And if both of those sides match, you know the capital letter A is symmetrical. It has symmetry. That's pretty cool. I like symmetry. Hey, next, how about we look at the capital letter Y? Does the capital letter Y have symmetry? What do you think? Yeah, it does. The capital letter Y has one vertical line of symmetry. You can see it right here. We know it's a line of symmetry because we look at both sides to see if they match. Do they match? You got it. Both sides match each other. Aw, best friends. I assume they match, they might be friends. When the two sides match, that tells us the capital letter Y is symmetrical. It has symmetry. Pause for a moment, even the music, okay? I need to share something with you. And no, it's not that my true dream and passion is to make cat-themed electronic dance music in honor of Mr. Whiskers, of course. It would be in honor of you, Mr. Whiskers. Let's be honest, it's actually a pretty good idea. I think people might like it. No, this is just something some people don't realize about symmetry, okay? Here it is. Lines of symmetry don't have to be vertical, meaning lines of symmetry don't have to go up and down. Lines of symmetry don't have to be vertical. Take the letter C, for example. Does the letter C have symmetry? Well, if we try a vertical line of symmetry, it would seem like the answer is no. These sides don't match. But wait, if we try a horizontal line of symmetry, do both sides match? Yeah, they sure do. So does the letter C have symmetry? Yes, it does. That means the letter C is symmetrical. Oh wow, here are more butterflies. They are symmetrical. They have symmetry. But I don't think they know that. They go about their whole lives, and I don't think they ever figure that out. Wow. Someone should tell them, right? I don't know. Okay, let's try the letter L. Does the capital letter L have symmetry? Oh, this is going to be fun. Let's check with a vertical line first. Then we can just look at both sides. Do they match? Yeah, they don't match. This is not a line of symmetry. Hey, that's okay. Let's check with a horizontal line, all right? Do both sides match? You're right, they don't. What? No symmetry. Oh. Okay, wait, what's Rover doing on the screen? And what's with the sad music? It's okay that the capital letter L doesn't have symmetry. It's fine. We don't have to be sad. Rover, I promise you, you don't have to be sad. Look, if something doesn't have symmetry, it's this special thing called asymmetrical. Asymmetrical, that's a long word. Asymmetrical. If a letter, picture, or shape has no symmetry, it's asymmetrical. Let's look back on the capital letter L. Remember, the capital letter L has no symmetry. We tried to see if it had a vertical line of symmetry, but these sides don't match. If the sides don't match, you have no symmetry there. Then we tried to see if it had a horizontal line of symmetry, but again, the sides did not match, so there is no horizontal line of symmetry either. The capital letter L has no symmetry. That means the capital letter L is asymmetrical. Asymmetrical means it does not have symmetry. There are other letters that are asymmetrical too. Look at the capital letter R. Let's try a vertical line of symmetry first. Do these sides match? You've got it, they don't match. Wait, how about a horizontal line of symmetry? Do these sides match? Yeah, they don't match either. The capital letter R is asymmetrical. Wait, how about a lowercase r? Can you tell just by looking at it? Is a lowercase r symmetrical or asymmetrical? a lowercase r is asymmetrical too. When you're looking for symmetry, you are looking to see if the sides will match. The lowercase letter r is asymmetrical because none of the sides match. If you try a vertical line of symmetry, these sides don't match, do they? And if you try a horizontal line of symmetry, these sides don't match either. Aha, a treasure map. Actually, this is just a regular map that looks really old. I tried to find footage of a treasure map that has our last letter, the letter X on it. Okay. But, you know, they have to keep the treasure maps secret. Maybe that's why I can't find that, okay? But the letter X is the last letter we're going to look at. I'm so excited because you are quickly becoming a symmetry expert, okay? So let's look at the letter X together. Now, just by looking at it, do you think it's symmetrical? Is the letter X symmetrical? Yes, it is. We can try a vertical line of symmetry first. Do both sides match? Yeah, they match. But here's the cool thing. We can try a horizontal line of symmetry too. Do both sides match? They do. That means the letter X has 2 lines of symmetry. Wow, that's pretty neat. Be warned, pirates. Some pictures, letters, and shapes have more than 1 line of symmetry. Okay, let's tie all of this together. When you are looking for symmetry, look for sides that match. The line down the middle that shows symmetry is called a line of symmetry. A line of symmetry. If it has symmetry, it is symmetrical. If it doesn't, it is asymmetrical. And if it is symmetrical, it might have more than 1 line of symmetry. So keep that in mind. You did such a phenomenal job. Have fun looking for symmetry all around you, looking for sides that match. That's symmetry. And you know what? You did it! You learned so much first grade math today. I am so proud of you. You worked hard, had fun, and did an amazing job. I think you are a math superstar. Wow, congrats on making it all the way to the end of the video. Oh my goodness. I hope you had a ton of fun. If you enjoyed this and haven't yet, be sure to subscribe to my channel. I have so many learning videos to explore. I want to give a special thank you to my patrons. Your support means the world to me. And thank you for watching. You are so awesome, and I can't wait to see you next video.